Hello, everybody. So, looking at chapter 5.3.1, we can see that the formula to find the magnetic field is very similar to the formula that we use to find the electric field. For example, in electric field, we used to do E times dA, the integral of this, is equals to the charge enclosed over epsilon naught. Instead, with the magnetic field, we do pretty much the same thing. And on the right side instead, we have mu naught times I enclosed. So pretty much the only thing that changes is the uh, constant. So here we will get that in the case of figure 5.27, so where we have a wire, the current coming towards us, as you can see, I use the arrow notation. The dot means it's coming towards us. Oops. Okay. So we have our magnetic field that is represented by these lines. Oops. We know that the magnetic field will be directed in this direction thanks to the right hand rule. So if you point your thumb towards you, then the rest of the fingers curl around the thumb in that direction. If we do this, we have to find the uh, area of a cylinder around the wire. And of course, the area of the cylinder is simply the surface of a cylinder will be 2 pi times s. So it will be b times 2 pi times s is equals to mu naught times I enclosed. And so we would say that b is equals to mu naught times I enclosed over 2 pi s. And as you can see, we proved what the book is saying. Um, Now instead, if we want to find the uh, radius at a single, all around the uh, circle, is like saying we have 1 point here, 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 1 point here. We're putting them all together. We would have something like this. So the sum of all the electric field. So this net would be equals to pi, I to infinity pretty much. Um, so we can just simply rewrite this as the integral on a closed loop b times dl, and we know that b is equals to this value that we found, oops, right here. So we would have, let's substitute b with this, so we would have mu naught times I enclosed over 2 pi s. And now we need to switch our dl for what is our dl. So dl for a cylinder is actually equals to ds in s hat plus s d phi in the phi hat direction plus dz in the z hat direction. So out of this, we will get, well, ds in the s hat direction. So we'll have ds d phi dz. Now actually dz we don't count because we're counting towards infinite, and of course ds from the d phi goes here. So now as you can see, we can cancel out these two s's, and everything else is a constant, so we can just take it out. We're going to have mu naught times I enclosed over 2 pi, and then we have over, oh sorry, in this case we have the loop, d phi, of course, from 0 to 2 pi, because we're talking about a closed loop. So it's equals to mu naught times I enclosed over 2 pi times, here we got 2 pi, so we cancel out with this part over here. And as you can see, in the end, we get it's equals to mu naught over I enclosed. That is pretty much all you need to understand from the first page. That is the proof. However, it starts talking about what happens if instead we don't have just one wire. We have, we don't have an infinite wire. Well, that's going to be something that is approached in the next section. And one other thing that we can do about this, because we know that I enclosed can be substituted with an integral of the current charge density, of course, times the area. We can say that the closed loop B times dA is equals to, B times dl, it would be. Yes, B times dl is equals to, we said mu naught times, substitute the I enclosed with the integral, so integral of j times dA, and we can use the Burgess theorem, or sorry, Stokes theorem, and so we're gonna have that the curl of B over an area, integral of this, is gonna be the same thing as the right side, because of course we know that since this says closed loop, we can just kind of substitute it with a normal integral and then do the curl of what's inside. So in that case, the B. All right. So now, as you can see, we have two integrals. Well, we can just simply cancel them out. It's a pretty straightforward operation. And well, of course, we're canceling out, of course, the dA and dA because they're the same dA. So we're gonna have the curl of B is equals to mu naught times the current charge density. And that is a proof that explain us what happens, what is the curve of a infinite loop, infinite wire.